Hello students, let us discuss about Lewis representation of simple molecules, which is known as Lewis structure. So first of all, see rules. To draw the Lewis structure, what are the rules? Let us discuss first of all. So let us see first rule. The first rule is nothing but here the total number of electrons. It is the first rule. We are taking a total number of electrons available for writing the structure are obtained by adding valence electron of combining atoms. What is the first rule we are discussing here? Total number of electrons. So what are the electrons available for to draw this structure, to get this structure? First of all, what we have to do, if you are taking two atoms, that should be combined. The valence electron, the outermost electrons is combined. So then total number of electrons we are getting. That one is for drawn for structure. So let us take an example here. CH4. Okay. So carbon is having valence electrons 4. Hydrogen is having 4 into 1. 4 valence electron. Okay. So total how many electrons it is having? Carbon is having 4 and this one is having 4. So by this what we can write here? What is the step 1? So we can do here 4 plus 4 is equals to 8. So to draw this structure, we got total number of electrons to draw this structure. Means what we have did here by combining atoms. So hydrogen is having valency 1, carbon is having valency 4. So how it is for it? Atomic number is 6, 1s2, 2s2, 2p2. So this is the valency we have got here. Okay. So this valency and this valency, if we have added, total combining atoms how we have got 8 electrons. So this is about first rule. So what we have did first rule, we have added the valence electron of two atoms. Okay. So in the second rule, what we are going to say is here anions. For anions, if you are taking here anions to the total number of electrons, anions to the total number of electrons from this step A. Means from this step for anions, total number of electrons we are taking. Okay. So then what will happen? The number of electrons equal to the overall negative charge is to be added. Observe clearly here. For anions what happened? Here we are taking total number of electrons from step A. From step A we are taking total number of electrons. Okay. So then what happens? The number of electron equal to the overall negative charge is to be added. So means what here? Let us take an example here. CO3 2 minus. Okay. So what is the valence electron from step A? We got 4. Okay. So the valence electrons is here 4 for carbon. And coming to here oxygen. So what is, which group it is? Sixth group. Okay. What I have told, the number of electrons equal to the overall negative charge is to be added. So this charge, number of electrons, so this charge should be added to the this valence electrons. In the second step what we are saying, the anion charge is added to the valence electron. So what will be the valence here? 3 into 6. Its atomic number, what is its atomic number? 6. Okay. So here what we are taking, what is the oxygen atomic number? Sorry, 8. Oxygen atomic number is 8. Okay. So it is having configuration 1s2, 2s2, 2p4. So what is its valence electron? 6. Okay. So this valence electron, how many oxygen atoms we are having? 3 oxygen atoms. 3 into 6. Okay. So this one you will be getting 3 6 are 18. So what we have to do now? We have to add 4 plus 18. So what I have told here? For anions to the total number of electrons from step M. So same process here also we have done. So this is the meaning. So next one, what? The number of electrons equal to the overall. So this electrons equal to the overall negative charge, it should be added. Means plus 2 we have to take. So what is the negative charge we are having? That should be added to this total valency electrons. So what we will be getting? 4 plus 2, 18 plus 2, 20 plus 4, 24. So this is the second rule. So what we have did first, in the first step we have counted valence electron. In the second step, what we are doing here? We are taking valence electron. If it is representing a charge, then we are adding that charge. So then we are getting this number. Next rule, what is the next rule here we have to do here? So what is the next rule? Let us see here. The third rule is nothing but here, for cations, the number of electrons equal to the overall positive charge is to be subtracted from the total number of electrons from step A. So here same thing will happen here. If you have been observed here, for anions we are doing addition. So coming to for cations means positive charge, we have to do subtraction. So coming to here, NH4 you are taking an example, NH4 plus an example here. So what will be the valence electron? Its atomic number is 7. So 1s2, 2s2, 2p3. So this is the valence electron. Okay. So you will be getting for nitrogen 5 plus 4 into 1. Why? Because hydrogen is having valence electron 1. So that's why we have written 4 into 1. Here what we have to do means, here we have to do subtraction minus 1. So here how many charges we are having? Plus, only one plus charge we are having. That's why I have written minus 1. So minus 1 is, if suppose plus 2 it is there, minus 2. Okay, if suppose plus 3 it is there, minus 3. So means what? For cation we have to do subtraction, for anion we have to do addition. So how many you are getting? 4 minus 3, 4 minus 1 3, plus 5 8. So 8 you are getting electron. So this is about step 3. So now next let us see step 4 here. What is the step 4 here? In the step 4, distribute the total number of electrons. Okay, so what we have to do? First we have to distribute the total number of electrons as bond pairs. So here as bond pairs between the atoms. Okay, So for this, the skeletal structure is, the compound is known or presumed. So what I have told, to distribute the total number of electrons as bond pairs between the atoms. So means what here? For example, CH4 I am taking. Okay. So whenever I am taking CH4, so by this what I have to bond pairs we have to draw. Okay. By this what we can know? By this the structure is known. So here hydrogen 1, hydrogen 1, hydrogen CH4. So this is nothing but bond pairs. So the total number of electrons. So here how many electrons we have got? 8 electrons. So hydrogen 1, 1, 1. Okay. So here total 4. Yes or no? For CH4 we are having like this 4 bond pairs. So we are writing like this. So 4 bond pairs. So this is the thing we are drawing. So next, in generally what is the next rule we can say? Means here in general, the last electronegative atom, okay, the last electronegative atom is the made the central atom of molecular ion we can say. Okay, so molecule or ion we are saying. So means what here? The last electronegative atom is made the central atom of the molecular ion. Means what here? I am taking NF3. Okay, so this is the electronegative atom. The F is consist of what? Last electronegative atom. So nitrogen is nothing but what here? Nitrogen is the central atom. So here what happening? Nitrogen is the central atom and the fluorines are the bonded atom. So this is the meaning of this point. So means what I have told you, NF3 or PCl5. So this last central atom, which one we are taking, this one will make the bond pairs. Okay, so next one, last rule, single bonds generally it was constructed first with bond pairs, then remaining electron pairs are utilized either for multiple bonds or for the lone pair of electrons. Okay, so means what? In each case, each of the bonded atoms except hydrogen, it will get an octet of electrons, we can say simply. So this is the octet representation. Mainly Lewis structure is nothing but what? Dot structure we can say. Okay, so what is the last point we can say? Means here single bonds are constructed first, with bond pairs. Okay, what we have discussed, first single bonds are constructed, means like this, the single bonds are constructed first with bond pairs, then the remaining electron pairs, are used either for multiple bonds or for lone pair of electrons we can say. Okay, so in each case the bonded atom gets an octet configuration. So by this, if you consider like this, so what are these rules? We are having total 6 rules. In the first case we have to count valence electrons. If you are taking anion, there should be an adding of valence electrons. If you are taking cation, there should be a subtraction of valence electrons. Next one, we have to distribute electrons. In the next step, the last electronegative atom will form the central atom of the molecule. Next one, if you are taking single bonds are constructed like this. So first of all, the single bonds, the 4 and carbon valency 4, total 8 valence electrons we are getting. So that is the meaning of this. Okay, let us see this one thing. So if you are taking examples like here, so example, if you are taking O2, okay, so if you have been seen O2 example, so here the Lewis dot formula, what it represents, what is the Lewis dot formula? So generally the dot will represents like this 6. Okay, so this is the Lewis dot formula. But what I have told you here, the valence electron total is 6 plus 6, how much we are getting? 6. O2 means 2 6 are 12. Total electrons we have got. So here there is no charge, so don't worry. So what I have told you in the next step, what I have told you for O2, generally the total number of electrons should be distributed as bond pairs. So here these two electrons, so these two are written as bond pairs, so remaining can be represented as lone pairs, or like this we can represent. Okay, so if you take O3, similar way you can take. So here O, okay, so here O and here O, 3 molecules. So total how many? Each O consists of 6 electrons. Total 6 electrons each O, means what? Total 18 electrons we should have to get. So this is the Lewis dot formula if you have been seen. So this one will be getting plus charge, this one will be having minus charge. Okay, so if you have been seen the bond pairs, so here plus charge means we have to do subtraction, means it is here 2 electrons is combining with another oxygen according to rule. 4 electrons it is having, and here one bond pair with minus you are getting. Okay, so like this we have to represent. And also if you have been written NF3, so NF3 can be written as like this. Generally nitrogen is having how much? Total 5. Okay, and fluorine is having, due to the presence of last electron is electronegative atom, so it can be written as 1 2 3 4 5 6 7 8. So total how many we are having? NF3 like this. So this can be represented as 2 lone pairs and 3 bond pairs. Okay, so these are the examples generally we are taking here. So let us take general examples. So I am taking generally here NO2 minus. I will be explaining you according to rules. So NO2 minus, in the first step what we have to do, we have to count valence electrons. So in the first step what we are doing here, valence electron, nitrogen is having 5 valency plus oxygen 2, 2 into 6. Okay, so total valence electrons for oxygen is 6, 2. This is the first rule. Coming to second rule, what we have to do, for anions we have to add. So here only minus charge is there 1, so that's why we are taking plus 1. So you are getting, this is the total 18 electrons. Okay, so these are the 3 rules. So now we have to write the skeletal structure. What we have to write here, we have to write the skeletal structure of NO2 is has been written. In this only first point, second point combines. If there is no cation, that's why we are not doing any subtraction. So next one what we have to do, we have to write the skeletal structure. That is, skeletal structure is nothing but O and O. Okay, so now what we have to write? To draw a single bond, okay, one shared electron pair between the nitrogen and oxygen atom, it should complete octet electronic configuration on oxygen atom. So means what here? Here total nitrogen is having how many valence electrons? Overall 5 we are having. 3, 4, 5. Coming to here, oxygen is having how many? 6. Okay, and what we are having? Minus charge we are having, if you have been observed. So means what here? It does not complete the octet on nitrogen. If you have been observed, 1, 2, 3, 4, 5, 6. If these electrons will share here 2 electrons, it will get 8. If these electrons will share here, it will get 8. But coming to here, what happening? Nitrogen is not having 2 electrons because it is having lone pair of electron to share the electrons. Okay, so that's why what happens? It is forming multiple bonds, we can say. So one side it is forming single bond, other side it is forming double bond. So means what? To share, if you share electrons, nitrogen is not having complete octet configuration. So that's why it is written as double bond N, oxygen, 2 electrons. Here 2 electrons it is having, and here one single bond, 6 electrons, minus it is having, or we can write it as like this also. It can represent whether oxygen, nitrogen, 2 electrons, double bond 1. So like this it can represent. Okay, so generally what is the general structure we can write here is N double bond O minus. And what is structure? Generally this is the, okay, so we are having minus here, that's why we are representing here minus. So this is the way to represent the Lewis structures like this. And let us take one more example, CO. If you have been taking CO, then you are getting here, as it is having valence electrons 4, oxygen is having 6, like this you can write, or it can be represented as with bond pairs. Okay, so this is the way we can write, or you can write it as like this also. So if you have been taken C2H4, okay, so carbon is having valency 4, and if you have been writing 4 valency, and 2 dots is for what? Hydrogen. 1 dot is for hydrogen, another dot is for hydrogen. So then you can write it like this also, C double bond C, which is occupied by multiple bonds and single bonds. So this is the way to represent what here? Lewis structure. So this is nothing but what? Rules of the Lewis structure. So now let us say about formal charge. It is next one, formal charge. Generally, Lewis dot structures do not represent the actual shape of the molecules. Okay, so it will not show actual shape. But what happens here in case of polyatomic ions, the net charge is written by a ion as a whole, not by a particular atom. Okay, but to remove that, means to remove that condition, to overcome that problem, so formal charge on each atom has been assigned. Okay, so the formal charge of an atom, generally what it says means, tells about polyatomic molecule or ion, difference between the number of valence electron in the free atom, which is means difference means what? Subtracting. Okay, and number of unshared electrons on the atom and number of bonds around atom. Okay, so this is what we are going to discuss here. So what is the formal charge? Formal charge is nothing but here formal charge may be regarded as the charge that an atom in a molecule would have. Means what here? It may or may not approximate the ionic charge. So what is the general definition of this is nothing but here the formal charge of an atom in a polyatomic molecule. In a polyatomic molecule or ion may be defined as the difference between the number of valence electrons in the free state or isolated state, okay, and the number of electrons assigned to that atom in the Lewis structure. So this is about formal charge. What is the formal charge? The difference between. So formal charge of atom in Lewis structure is nothing but here. What we can say here? Formal charge is nothing but difference between means what? Subtracting. Number of valence electrons in the free state minus, okay, so we are doing minus, and number of unshared electrons on the atom, okay, which is not shared on the atom, and next one number of bonds around the atom. Number of bonds around the atom. So this is nothing but formal charge of a polyatomic molecule, how we are representing. So now let us consider ozone, O3. The structure is like this we are having, okay. This is the structure we are writing. So here the atoms have been numbered as this is 1, this is 2, these are 3 atoms we are taking, okay. So here the central O atom marked as 1, yes or no? So this is marked as 1, okay. So means what here? This first atom we are taking to the first atom, the first one we are taking now, so I have written first one. So the central O atom marked 1. So we have written how many? So how many valence electron we are having? 6. 6 minus, and here we are writing 2, and here we are writing 3 is equals to plus 1 we are getting. And coming to second point, what happens here? The end O atom marked 2. Yes or no? This marked as 2. So it is having 6. Here how many electrons we are having? 4. And here 2. So it represents 0. If you have been taking 3, the third atom, and it is having 6, 6 minus 1 is equals to minus 1. See, clearly observe, in the first atom what I have taken, here oxygen valency is common for everything. Okay, so next one, 2 electrons we are having, here 3 valence electrons we are having, that's why we got plus 1. And again for second atom, oxygen valency is 2, so here it is having 4 valency, and here it is having 2, that's why I have written 0. Coming to here 6, third atom, 6 minus 6, and it is having minus 1, so that's why I have written minus 1. Okay, so this is nothing but how to represent the number of valence electrons in the free state. So first step what I have told you, free state means oxygen is having 6 valence electrons minus number of unshared electrons on the atom. How many electrons it has unshared? First atom, 2 electrons it has not shared, that's why I have written 2. Okay, so number of bond around the atom. So how many bonds we are having? 3 bonds, so that's why I have written 3. So it is getting plus 1. If you have been taking 2, in the free state the valency of oxygen is 6. So how many unshared electrons we are having? 1, 2, 3, 4. 4. So how many bonds it is representing? Total oxygen is representing only 2 bonds to the first oxygen. That's why I have written 2. Coming to here, if you have been seen, 6 valence electrons, which is not shared 6 electrons, and how many bonds it is sharing? 1. So that's why I have written minus 1. This oxygen only sharing 3 bonds. If you have been taking this oxygen, it is sharing 2 bonds. If you have been taking this oxygen, it is sharing 1 bond. So clearly observe here, ozone molecule I have taken. Okay, these are the electrons I am taking. So what is the valency of oxygen? 6. Okay, what I have told, the number of valence electron in the free state. Valence electron means outermost electron is 6 here. For the first atom we are calculating. So how many unshared electrons here it is there? 2 unshared electrons. That's why I have written 2. So how many bonded atoms it is there? 3 bonded atoms. That's why I have written 3. Coming to second atom. This is the second atom I have been taking. So what is its valency? Oxygen is having valency 6. So here how many unshared electrons? Total 4 electrons it is unshared. How many bonds it is sharing? So bonded around the atom is only 2 bonds. That's why I have written here 2. Coming to third atom. So it is having valency 6. So how many unshared electrons? Total 6 unshared electrons. How many bonds it is sharing? 1 bond. So that why I have written minus 1. Okay, by calculating this all, this is the value we have got. So this is about formal charge. In the next class, let us discuss limitations of the octet rule. Thank you.